and I introduce you. Yeah. So, Mr. Florian Wohlrab. Oh, so it's not so easy to pronounce your name. Sorry. Florian Wohlrab. Yeah. Yes.
Yes. Correct.
Yeah.
Thank you.
Okay. He is one of the first RISC-V ambassadors and head of sales of EMEA and Japan at Andes Technology. His mission to help bring RISC-V towards mainstream and enable others to easily get started within the RISC-V ecosystem. So he is fascinated by the open, modular, compact, and innovative RISC-V CPU designs. Before joining the Andes Technology, he worked in industrial PC and IoT fields, holding various technical and business roles within Europe and Asia. So I expect a good presentation from you. Will you start this?
Thank you very much, Niwa-san. Hello, everyone. Let me share my screen with you. So, hello and konnichiwa. My name is Florian. Like Niwa-san said, I'm the sales manager at Andes Technology for Japan and also Europe. Today, I want to give you an introduction about Andes, but more importantly, about RISC-V. Because like Callisto already said, RISC-V is the really important architecture. It is changing things. It has a lot of traction. Also, so many people in Japan join. And also like Jeroen from Espressif just before said, the RISC-V was giving them more flexibility for the ecosystem because it's more open. So today my title is RISC-V, How and Why. And I first want to start, and I want to start by saying which age we are in. So the age we are in, I think, is the age of the domain-specific architecture. That means you can add your domain-specific architecture and the instructions you want, like Jeroen said, say adding it Espressif to make it more fast, to make it more better for AI. But another important point is also improved security. Things are continuously connected to the internet. Things are continuously exchanging data. You need to make sure that your messages are encrypted or set your messages correct, so the sender can kind of put a hash sum and the recipient can check if it's the correct machine, if he's controlling something, but also for protecting your device so it's not getting hacked. And then the next one is agile. I mean, if we are seeing how fast chips are developed today, it's really breathtaking how fast it goes. So things need to be more fast, and therefore an open standard like RISC-V really can help people to collaborate more easy on the same goal and speed things up. And then last but not least, the age of open ISA. The open ISA means that you have an instruction set architecture, and this instruction set architecture is open, so it's not owned by a company. It is not heavily armed by patents where no one is allowed to implement it. No, RISC-V, everyone can implement his own core. Companies can implement a core and sell it with all the support, with all the verification done, but also students can make their own core. So all this here in Andes, we believe it is the age of the golden age of the computer architecture because it enables so much innovation. It enables so much more collaboration. But let's have a look why RISC-V. Why is RISC-V now everywhere and how does it go, sir? Well, RISC-V already came in 2005 and some people ask me, why was it not immediately, sir? That is kind of easy. While academia are adopting it very fast, in industry, the cycles are more longer. It takes more time to be adapted, to be taped out, to be reviewed, and then others taping it out that are cycles 1 year, 2 years, something like this. But what we are seeing now is that RISC-V already started in 2015, already proved in so many commercial designs, it's already mature and it's really speeding up. So many companies have already taped out RISC-V, so the acceleration is growing and growing. Then another case for RISC-V is that customers have different use cases. Some customers want to have a very low power core, others need to have a very efficient core, crunching numbers, they don't care about power consumption. And then some people only take one core, others take many cores. We have seen designs in Andes, for example, with 100 cores, but we also have a startup doing some super interesting number crunching where they put 1,000 of our cores into one design. And then another point is RISC-V allows for greater flexibility. First, you can add custom instructions and you can speed up your specific workloads. That can be an FFT analysis, that can be an FIR, or that can be a convolutional neural network for your special case. Sometimes in your application, in your specific application, having a custom instruction, speeding this up, implementing it in hardware can make a huge difference. And that's where we expect also to see a big innovation and a big stream towards RISC-V. And then last but not least, you need to have an ecosystem. And it takes time for an ecosystem to start. And then there are so many different projects, like if you're looking for open source, for example. And what we see for RISC-V, the ecosystem is now ready. It started so many years ago. There are so many people contributing and building on it, and it really make a big difference. So RISC-V ecosystem, you can use it right now and start designing your project. Another why RISC-V is now becoming more popular, because more and more companies adopting RISC-V. For example, here in Andes Technology, last year we have signed a license agreement with Renesas. So Japanese Renesas has licensed Andes RISC-V. Actually, Renesas has licensed several different cores from low performance to medium range performance, and they are putting it in their microcontroller units. So you will see ASSPs and ASICs very soon from Renesas with Andes RISC-V, and that will be millions of cores. So more people will get familiar with it, put their hands on it, and build all this ecosystem even further. Then also Thailand, for example, a company from Greater China, they have developed a Bluetooth audio chip. So they put our RISC-V inside and they leveraged our DSP. In RISC-V, you have the DSP/PACT-SIMD extension. It's called RISC-V-P extension, and that was used by Thailand. Now, Thailand's end customers are used to program in IR systems, who also will speak here on the RISC-V day. And Andes is a very good partner of IR system. IR system and Andes have partnered, and we made this extension of RISC-V to make it available and be programmable via IR. So Thailand has chosen Andes because they can use the RISC-V and program with IR, not only depending on Andes. Other companies, for example, Picocom, very interesting. Here we are talking about many cores. They are putting 32 cores into one system. It's a 5G Open RAN cell, a small cell, so that can be reprogrammed by customers. And then last but not least, AI accelerators for servers. Here we also see a huge demand. There are multiple factors. For example, RISC-V is offering a vector extension. Now, what the vector extension allows you is to make higher number crunching, to put more cores together and crunch all these numbers. And now we have customers who are putting several of these cores into one AI accelerator. So that's, from my point of view, also one point why RISC-V, because more and more people, diverse use cases, a Bluetooth chip, a general microcontroller unit or motor control, but also 5G, and then up to the data centers with accelerators. Everywhere is RISC-V coming because of flexibility, openness, great ecosystem. So we expect to see, like Callista said before, really going through the roof. Another solution for RISC-V is the custom instructions, or a data path acceleration, if we call it in general. So RISC-V has several solutions. The first one is the RISC-V P extension. That is a DSP packed SIMD extension. It is using existing GPRs, so it's very easy to program, and it's for audio, voice, small image, or slow video. The next one is the RVV, the vector extension for RISC-V, and here you're looking into high data rate computations, like for video streaming or radar applications, like a radar in a car, for example, but also to detect people in a room. But you're also looking for cameras taking the input, finding what is in the image, if there is, for example, someone in the meeting room or how many people. And then last but not least, you can add custom extensions. So you can make your custom instruction. And here at Andes, we actually have a very nice tool who is taking your input, your Verilog code, and generating it together with the core, adding also or creating also the tools you need, like debugger, assembler, compiler, and so on. So you have for RISC-V 3 different ways to accelerate your data paths. You can have the P extension out of the box, very easy. You can have the vector extension, very powerful, very big for number crunching, great. And then you can make your Andes custom, you can make custom extension to bring this custom AI function or this custom function you want to do into the RISC-V core. And by the way, the RISC-V specification, that's one of the great things, allow you to add custom instructions. Last but not least, some people also ask from software side, yeah, but how can we simulate all these things? Here again, RISC-V and open source, a great environment where many companies work together, and Andes is here working with Imperas. So Imperas can take all the input and simulate it in a very fast space. And there is also an open source simulator from Imperas available. Now, how we go, sir, and the how you can see here, with hundreds of companies, really hundreds of companies, and you see so many companies here. You have many Japanese customers already joining. When you're looking here, you will see Sony, you will see Renesas, and many others. You have American companies, many companies from Greater China, but also European companies, and you even have Australian companies like Morse Micro. So here Andes is really working, and we are working with many others, and that's how RISC-V will become mainstream. Why? Because everyone is using it. How? Through several of these customers or companies working in RISC-V. So let me give you some more introduction quickly about Andes, who we are. Andes is a pure play CPU IP vendor. So we do one thing, and that is CPU IP. And that's what we are doing very good, very power efficient, and just right for our customers. Andes is also a RISC-V founding and a premium member, and we are a major open source contributor and maintainer. We are heavily engaged in RISC-V because we see it as the future. So for example, myself, I'm a RISC-V ambassador. Then our CTO is a technical steering committee vice chair, and our CEO is a director of the board in RISC-V. Andes is also a public company, so we are this year 16 years in business, and we have over 200 commercial licenses. We also do have some academic licenses. These are not included here. The shipment of our commercial cores through our customers is now over 7 billion cores. And because we are working mainly on pure CPU IP, the majority of our people is working in R&D. And the R&D here actually is different parts. Of course, the biggest part is the CPU IP development, but we are also having people working in the software department, helping to maintain U-boot, helping to update and streamline things for GCC, for Linux, and so on. Andes itself is headquartered in Taiwan, so we are a Taiwanese company, but we have branch offices all over the world. So we are in Japan, actually, we are in Korea, of course, Greater China, Israel, Europe, in Netherlands and France, and also in the United States. Let me give you a quick overview about our roadmap. Our roadmap ranges from small cores like a 2-stage core over our 5-stage cores. And then last but not least, we also have a 27 core that is still a 5-stage core, but it has an enhanced memory management. Next core is the 45 core. Here we have an 8-stage series. And what you can see is that we are ranging from the left side, which is an embedded controller, for example, like Espressif before Jeroen showed. So that would be a typical core you put in an embedded core. Then if you do some more number crunching, you can see our data processing cores here. And then last but not least, we are adding also a memory management unit, so you can run an embedded Linux. And we also have cores which have L1 and I/O coherence, as well as L2 cache. So it's a multiprocessor cluster for running Linux on multiple cores. What we think is great in RISC-V is the data processing. And here actually we are also having our vector processor, which is a 5-stage CPU IP together with the vector processing unit, which can be highly configured by our customers. So there are many hardware options from 128-bit up to 512-bit once this IP is licensed. And then last but not least, we also have our high-end application processors. So for example, if Espressif is looking for something to run Linux, maybe our AX45MP could be interesting. If it should be a little bit smaller, the AX25MP could be an interesting choice. Let's have a short look into our AX25L2. That is a core where we are adding a standard core 5-stage with memory management unit, and we have been adding an L2 cache. So the L2 cache is helping to speed up the frequency or speed up the execution of the program for a single core. It is highly configurable. For example, 2 tech and data banks, bank interleaving, SRAM latencies can be programmed. The interface of the core is, of course, the standard EMBA. So here we are having AXI. And then you have local memories for instruction and also data, and that can be pre-programmed. Why should we add an L2 cache? If we are looking at this, what we are seeing, if you're especially running an operating system, an L2 cache will increase your memory bandwidth by the factor of 2.1, and the latency will decrease by 30%. That means if you're running, for example, a benchmark like SpecInt 2K, your total performance by adding an L2 cache will be increased by almost a factor 2. Now, let me give you a very short overview about the 45 series. That is our high-end core. It is an 8-stage in-order dual issue. So most instructions can be independent or pair with 1 or 2 ALU instructions. We also have, again, the memory boost system to make the memory access more faster. Virtual memory support, if you want to run an operating system, is very important. So we have added this, of course, here. You have shared TLBs up to 512 entries. And we also have physical memory support. So if you have some cases where you need to protect your memory, the PMP and the PMA actually are quite good. Because we are working more for the commercial side, we also have implemented a feature which is cache lock support for the L1 caches. So it can lock your cache, and it can make sure that, for example, if you have a real-time service interrupt, this is always in the cache. The CPU don't need to look it up from the memory, and therefore speed up this speed enormously. The 45 series is also available as a multi-core system. So you have a coherence manager, which is MESI-based and director-based for scalability. So that means you easily could add more cores later. So far, we are planning to support 1 to 4 cores. And then you also have an L2 cache controller, which is similar to the one I introduced before. This whole system is already Linux SMP ready, so we have it up and running, and our customers actually already testing and implementing this. The performance of the 45 series, which is a 8-stage dual issue compared with the 27 series, is actually also quite impressive. So in total, we are seeing that we have speedups for the core mark of 1.7 for 32-bit and 64-bit roughly. And also the memory bandwidth in the 45 series is 35% higher than the 27 series. The maximum frequency we are having here right now is 2.4 gigahertz at 12 nanometer. So that's also something we see more and more in RISC-V, that the frequencies, the maximum frequencies are getting more and more higher, and that RISC-V is also coming into high-end processes. So for example, Andes also has customers using 7 nanometer already at this moment. Last but not least, I want to give you a brief overview about our NX27, which is our vector processor. It is based on the 27 series, which is a 5-stage core, but here we have added additionally the vector processing unit. And let me jump to the next picture. Here we will have some more detailed overview. So first, the data standards we are supporting is from int8 up to int64, and floating point 16 to floating point 64. And additionally, also very important, and this is supporting the extended bfloat 16 or brainfloat 16 from Google, and also int4, because that's what we see is really needed for a lot of AI application nowadays, especially if you're going into something like neural networks that can make a big difference. The VLANC is very configurable, as I said before. And what we have here is 2 independent memory access. So you can have the RISC-V load and store instruction, or the second one, you can make a custom instruction to load and store. This custom instruction actually we are calling streaming port. So why should you have a streaming port? With the streaming port, when you have a load store instruction, it goes over the standard bus from your CPU, and it needs to share with loading all the instruction for the CPU. And with the streaming port we are implementing, with this custom load store, if you want to say like this, you can have a faster load store. So you can, for example, have a hardware engine or a smart memory or an AI accelerator, and you really can tightly couple it to the CPU and exchange data without the need to go over the bus. And that has 2 effects. First, it is saving a lot of energy because you don't have all the bus access cycles and the handshake protocols. And secondly, it also can speed up enormously. What we are seeing is that with our vector processor and with the streaming port, now customers start building something like this. We call it a process element. So you have the vector processor unit with the streaming port and the hardware engine tightly coupled, which can directly access data from the memory through DMA or so. And now customers taking this and taking many of these processing engines together, combining it with some level 2 cache, and this whole thing will have in parallel some small control subsystem, for example, our 45 series or 27 series, which will get the numbers from the outside world or the workloads and then instruct the process engines what to do. So you get a very powerful, reconfigurable, in-software reconfigurable system on your ASIC with a possible scenario like this. And this is also working on programming support. That is very important. So we are adding OpenCL. That is what we are working right now to make it more easier for programmers to access this. Now, last but not least, the Andes Sentry security framework. That is my almost last slide. I only have one more. What we see is that security is becoming more and more important. We have cyber attacks up down to physical attacks. That means someone who is trying to attack your computer over the network, or someone who is trying to run programs via side channel attacks or something like this. So people need to pay more attention for security. And here at Andes, we are working together with many of our companies, like Rambus in Japan is also very strong, or Silex inside SecureIC, Hex5. And what we are working is to provide a security solution or a framework which is known to work, which is pre-certified, where we already make sure with our partners how to connect things, so it's kind of working out of the box. And we provide this to our partners to make sure it's more easy for people building on RISC-V to add all the security, to have a root of trust, to have secure message exchange and things like this. So the security framework Andes is now offering, or we are working on, is really a mix between hardware and software. Let me wrap up my presentation from today. I have shown you the lineup of our Andes RISC-V processors, which are from small power-saving MCU to powerful vector units, and from single core up to multiprocessor with L1 cache and I/O coherence. I have specially showed you quickly the A27, the A45, and the vector processor. And of course, we also have covered the question, why RISC-V and how? So, Andes Technology, I hope we can become your trusted partner. With over 7 billion cores shipped so far, and being a 16-year-old public company, working already with many great Japanese companies like Renesas or Socionext and many others, we are thinking we are in a good position to offer you a very reliable and power efficient yet strong core for your next ASIC. That actually brings me to the end of the presentation, and thank you very much. Are there any questions?
Oh, yeah, thank you. Thank you for a good presentation. Sorry, it's not time is over, and the system is not so stable. So yeah, but one question. Sorry, it's not so from audience, but yes. I have one question I'm interested in. So your presentation includes yeah, just a moment. Okay. CO pilot tools, co-pilot tools, maybe I'm not sure how to pronounce,
yes.
What to say. This is interface between different level of CPU or such a design. It's a RTL model and ISS also. Is it all understood or some combination
actually
of
an own
source
tool.
All understood. This is maybe it's very excellent.
Thank you. The co-pilot, what it does, if you create a custom instruction, he will take the input, the idea from the designer, and he will help to make it to add to the CPU code, which is plain Verilog, and also add to the tools. So actually, co-pilot is a little bit like an EDA design tool. It helps customer to design custom instructions.
Okay. So it's a very convenient for the customers
yes.
who use this board.
Yes.
Oh. Maybe it's making some good idea to solve, and it's something creative. So
thank you very much.
Thank you so much.